So yesterday we started with frequency domain analysis of RL circuits. So that is resistor and inductor circuits, right? So now let's proceed further to frequency domain analysis of what it will be, obviously resistor capacitor circuit, right? So we'll have a capacitor, right, and no inductor because it is just RC circuit. Okay. So again, I'll draw that diagram how a capacitor is replaced from time domain to a frequency domain. So I have this I of t, I have this capacitor C, and it has a voltage as V of t here. So how is it transformed? So this becomes what? V of S, right? So this is plus, this is minus, this current is as it is. And we have the capacitor, but its value changes from C to 1 upon Cs. And we have a voltage source with plus minus in this direction, and this value is V of 0 by S. So this you should know. So again we had done this using KVL, so you don't need to add this. Okay, so I have just revised it. So let's straight away jump to numericals. So the question goes like this: in the network, switch is moved from A to B at t equal to 0. Determine I of t and Vc of t. So initially, where is the switch at t equal to 0? Sorry, at t equal to A. So what is the first step always? That at t equal to 0 minus will write, right? So let's go in that direction and start. So as usual, first step is at t equal to 0 minus. What is this called as? Just before switching. So switch is in position A, right? So the circuit will be somewhat like this. So what will happen at when the switch is at position A? Obviously it is assumed that it is in steady state condition before switching from minus infinity to 0 minus. So inductor was replaced by short circuit externally. So obviously capacitor will be replaced by open circuit. So this is 10 volts, this is 1 ohms, right? So what will be the voltage across this? So this will be V6 farad of 0 minus. So why am I mentioning 6 farad and not C is because I have two capacitors, right? So what will be V6 farad of 0 minus? So V6 farad of 0 minus will be what? This 10 volts will drop here. So this is 10 volts. There will be no voltage across 0 minus, right? So it will be 0 volts and current I of 0 minus will be 0, right? So next what will we say? Since the voltage across capacitor cannot change instantaneously, so therefore V6 farad of 0 plus equal to 10 volts, V3 farad of 0 plus equal to same, which is 0 volts, right? So then we'll write at t greater than 0. At t greater than 0, the circuit will look like what? So switch is at position B. So like this. So 6 farad, 1 ohms, 3 farads, right? So 6 farads, 1 ohms, and 3 farads. So this will be what? 1 by 3s, because as we saw, a C in time domain changes to 1 by Cs in frequency domain. So this will be 1 by 6s, right? So, and what is happening further? We should have a voltage source plus minus like this, right? So it should be what value? V of 0 by S. But how is the current flowing here? If you see here, the current will flow in the upward direction, right? This polarity we have drawn for downward direction, right? So how will it be? I messed up the pages. So this will be the same, plus minus, and the voltage across here is 0, so there is no need to draw the voltage source, right? So this value is V0. So voltage across 6 farad is 10, so 10 by S, and this was 1 ohms. So this will be our Vc of S. It is given in the question. So this is given as Vc of t. So in Laplace domain it becomes Vc of S, right? So again apply KVL. So applying KVL. So therefore 10 by S minus. So this is the impedance now, right? So R into I. So 1 upon 6S into I of S minus 1 into I of S is I of S minus 1 upon 3S I of S equal to 0, right? So take this all I of s terms to one side. So I of s I am also taking common. So 1 by 6s plus 1 plus 1 by 3s equal to 10 by s. So therefore, so what will this be? So 6s. So how can we solve this? So this will be 2 by 6s. So 3 by 6s. So I of s into, so this will be what? 1 by 6s. So I want 6s here. So multiply by 2. So here also multiply by 2. So 2 upon 6s. Right? So 3 upon 6s, which will be 1 by 2s. Right? So 1 by 2s plus 1 equal to 10 by s. So therefore, this will be 2s plus 1 upon 2s equal to 10 by s. So s will get cancelled. So I of s is 10 upon SS is getting cancelled. So 10 into 2 upon 2s plus 1. So as we saw yesterday, we want coefficient of s to be 1. So therefore, I of s is 10 upon s plus 0.5. So what is this I of t taking inverse Laplace transform? 10 e raised to minus 0.5 t for t greater than 0. So are we done with the sum? No, we are not done. Why? Because they have also asked VC of t. Right? So how will we find VC of t? So it is here. So it is voltage across this capacitor. Right? So what we can write voltage across this capacitor? We know V is IR. So in this it will be V is I into Z. Where Z is the impedance. So what is the impedance? 1 by 3s. Right? So what will be VC of S? So VC of S will be impedance is 1 by 3s into current. So I of S. Right? So what was our I of S? It was 10 upon s plus 0.5. So equal to 1 upon 3s times s plus 0.5. Right? So what will you get? 1 by 3 is constant, so don't worry about that. So this will be s square plus 0.5s. So if you observe in all the properties and definitions, we don't have this form. So what we have to do, we'll have to use partial fraction expansion. So we'll write using partial fraction expansion. So what will this become? VC of s is a upon s plus b upon s plus 0.5. So again we can use the shortcut method. Right? So substitute s equal to 0 everywhere except this s. So it will be 1 upon 3 s into 0.5 plus s is now minus 0.5. This is 10, sorry. So this will be 10. Then s is minus 0.5. Substitute everywhere except this term. So 10 upon 3 into minus 0.5 into this is as it is. Right? So what will you get? Therefore, VC of S is 0.5 is half. So 20 by 3. So 20 upon 3S plus. So this will become minus. So again 20 by 3. So minus 20 by 3 times S plus 0.5. So taking inverse Laplace transform. So what will this be? VC of t equal to, so 1 by 3 ka inverse Laplace transform is 1 only, so 20 by 3, that's it, minus 20 by 3 into inverse Laplace of 1 upon s plus 0.5, so e raised to minus 0.5 t, right? And this exists for t greater than 0. So this is our final answer, right? Let's proceed further. Then I have this particular sum. So the switch is closed at t equal to 0. Determine the voltage across the capacitor. So first, this is the capacitor, right? So voltage is Vc of t, right? So switch is closed at t equal to 0 means at t equal to 0 minus it is open, right? So at t equal to 0 minus, so it is open. So what will happen? It is open, so nothing is happening to the inductor, right? So I can say Vc of 0 minus is 0 volts. Then you will say since voltage across capacitor does not change instantaneously, therefore Vc of 0 plus equal to 0 volts, because both will be equal, right? So then what you will say? At t greater than 0, switch will be closed, right? So 10 will become 10 by S, remember. So voltage source always becomes, in Laplace domain, the value of the voltage into its Laplace transform, which is 1 by S. So you can think of it, it is 10 into 1. So 10 into Laplace transform of 1 is 1 by S. So in that way you can remember. So this will be as it is. And since the voltage is 0, so this will be what? Directly a capacitor and no voltage source in series. But the value will become 1 by 2S. And this is Vc of S. Right? So this is 10 ohms. This is 10 ohms. This is 10 by S. Right? So next what we have to do? We have to find Vc of S. So again what we can do? We can assume this is Vc of S. Assume in the sense it is actually Vc of S. This plus this is minus, right? So better you take this as Vc of S, because you will get the answer for Vc of S in one equation using KCL. So applying KCL. So what you will get? So let's say this is the node. So all going away. I am taking this as the node. Okay. Taking here, it's one and the same. So it will be Vc of S minus 10 by S. This is a voltage source, remember, upon 10 plus Vc of S upon 10 plus Vc of S upon this is what? Resistor, right? So upon 1 upon 2S, everything is done, so equal to 0, right? So then collect the terms in Vc of S. So therefore Vc of S into, what is it? 1 upon 10 plus 1 upon 10. So 1 upon 10 plus 1 upon 10. 1 upon 10, 1 upon 10. This will be what? 2S. So plus 2S. This is what? Minus 10 upon S upon 10. So minus 10 upon 10S. So minus 1 by S. That is the only constant. So here it will become 1 by S. So equal to 1 by S. Right? So therefore Vc of S into this will be 2S plus 1 upon 10, 2 upon 10. So 0.2 equal to 1 by S. So again take it to the right hand side. So this will be 1 upon S times 2S plus 0.2. So again we do require the denominator, coefficient of S to be 1. So Vc of S is 1 upon 2S into S plus 0.1. I have taken 2 common, right? So again you will require what? Partial fraction expansion. So this is A upon S plus B upon S plus 0.1, right? So Vc of S equal to, so you have to write the steps using partial fraction expansion, etc. So S is 0 here everywhere except this S. 1 upon 2S into 0.1 plus, so S is minus 0.1 now. So 1 upon 2 into minus 0.1 into S plus 0.1. So 2 into 0.1 is 0.2. So therefore Vc of S equal to, so 1 upon 0.2S, so that will be 5. So 5 upon S. So this will be also minus 5 if you calculate, right? So minus 5 upon S plus 0.1. So taking inverse Laplace transform, it will be 5 minus 5 e raised to minus 0.1 t for t greater than 0, right? Quite simple. So let's take one more sum. So in the network, sorry, in the network the switch is closed for a long time, and at t equal to 0 it is open. Find the current through capacitor. So this is the capacitor. So it is I1 of t which we have to find. Right, so they have given these two currents, okay, and this is the switch, this is the current source. So instead of voltage source we have a current source. So again at t equal to 0 minus, what is happening to the switch? It is closed, right? So what will happen, can you tell me, if it is closed? If this is closed, entire current will flow here only, right? So what will happen? So I1 of 0 minus is 0, I2 of 0 minus is 0, right? And what will be Vc of 0 minus? It will be 0 volts. So since current through inductor does not change instantaneously, so Vc of 0 plus is also 0 volts. If you want, you can write I1 of 0 minus, I2 of 0 minus is 0, but that won't be required. Okay. So next, what we will do at t greater than 0? So at t greater than 0, so what will happen? Switch is open, right? So I guess I had told you consider this as 2 into 1. So in Laplace domain it will become 2 into 1 by s. So 2 by s. So switch is open. So there was no voltage across capacitor. So no question of voltage source in series. So this will be our simple circuit. So this is 1 ohms. 1 ohms. This will be what? 1 by 0.5 s. So 1 by 0.5 is 2. So 2 by s. And this is given as I1 of s. This is given as I2 of s. Correct? Have I missed anything? No. So what they have asked, current through the capacitor. So what would be the simplest way to find it? Using KVL or KCL? KCL will be simpler because you have only one node, right? So assume this is V of S. So once we find V of S, we can use voltage and current relation to find it, right? So I am writing here so that I don't have to change pages. So applying KCL. So what will we get? So again assume all currents as outgoing. So outgoing, outgoing, outgoing. So this is in opposite direction. So this will become what? Minus 2 by S plus V of S minus, what will this be? This is impedance. This is also impedance. So V of S upon, what is this? They are in series. So 1 plus 2 by S, right? Plus, so this is V of S upon 1 equal to 0, right? So we just need to solve this. So I'll write it here. So minus 2 by S plus V of S into, this will be what? S plus 2 upon S. So inverse will be S upon S plus 2 plus 1. Am I correct? Yes. Equal to 0. So to simplify, I can take this to the right hand side. So therefore V of S into, so S plus 2 plus S. So 2S plus 2 upon S plus 2 equal to 2 by S. So therefore E of S equal to 2 by S and 2S plus 2 upon 2S plus 2. So what is happening here? So if you solve this, you will get as S plus 2 upon S times S plus 1. So you are getting a S term here and S square term here. So you can solve this using partial fraction etc. again, but it will become quite complicated as compared to the previous sums, right? So it is better we apply KVL only here. Okay. So this is the way you have to think while solving the sums. Okay. So let me take this again and solve it. Again, if you want, you can solve it using the method which I was using. Okay, but I think, so I was just showing that you can use different methods. Okay, so let's use KVL since it will be simpler in this particular case. So using KVL, what will be happening? So if I apply KVL here, what will I get? So these current directions are already given. I want to write in those terms only. This current is going like this. So this is positive, negative. Let me use a different pen. So this is positive, negative. This is positive, negative. Right? Let's say I am applying in this direction. Right? But this current is coming from here. So this is minus. This is plus. Right? Current flows from higher to lower potential. Right? So I am going in opposite direction. So that is the important catch here. So it will be minus 2 by S I1 of S minus I1 of S plus I2 of S equal to 0. So what will I get? 2 by S I1 of S plus I1 of S equal to I2 of S. So let's say this is equation 1. Right? Next, what I can say, 2 by S is I1 of S plus I2 of S. So I am applying KCL now. So applying KCL at node so and so. So 2 by S equal to I1 of S plus I2 of S. Right? So I've got two equations, two unknowns. So I can find I1 of S and I2 of S. Right? So let's substitute what I want. What is the question? Find the current through capacitor. Means I want I1 of S. Right? So I'll try to eliminate I2 of S. So I2 of S is what? 2 by S minus I1 of S. So from this I get 2 by S I1 of S plus I1 of S. What is I2 of S? 2 by S minus I1 of S. Right? So this is simple. So therefore, what will this be? 2 by S I1 of S. So this I1 of S will come here. So plus 2 I1 of S equal to 2 by S. So what is I1 of S? It is 2 upon S upon 2 by S plus 2. So I multiply by S by 2. So it will be 1 upon 1 plus S. So it is nothing but 1 upon S plus 1. So what will be I1 of t? E raised to minus t for t greater than 0. Right? So actually it becomes simpler in this way. So if you want, you can use the KCL method also, but it will take a longer time in this particular example. Okay. So we'll stop here.